Hi everyone, can you hear me? Let's wait for one more minute. Hi everyone, so welcome to another new session on Python and machine learning. So in today's class, we'll focus more on the deep learning side of things. If you are a beginner or if you are attending this class for the first few times, so my name is Arun and I'm co-teaching with Tim. So we've been teaching for nearly 2 years, I think more than 2 years. So we focus more on machine learning, Python, deep learning, and also we share lots of tips and tricks, especially related to applications in the industries. So in today's class, we'll learn about some of the PyTorch. So I'll give you some quick overview on what we are going to learn, and then we will see one by one. Okay. So in today's class, we will try to understand more about the cross entropy loss function. So in the last class, we have seen some quick introduction on cross entropy, but today we will learn more about cross entropy and answer a lot of questions that raised in the last class. And second, we will learn about linear or any regression. We will solve one regression problem and one classification problem. So while solving these two problems, I will explain more about how to choose some architectures, how to choose the neural network architecture with different layers and different neurons, those kind of things. And after seeing these things, we will learn more about some new packages like PyCaret and Pandas profiling. So I think we have used Pandas profiling the last, I think 6 months ago or something. We will revisit this again. And PyCaret, I think this is new for us. I have used PyCaret to quickly explore some of the modeling opportunities, but I'm going to use this after a long time, like after 8 months or so. So it's relatively new for me. I haven't prepared anything for PyCaret and Pandas profiling because I have used this before. I'll do it live. I know the package names, so we will quickly read some documentations and do it together using one of the datasets that we are going to use for our modeling today. So, okay, I'll before going to the modeling side and explain the cross entropy, I will give you a quick 2 minutes introduction on the entire flow. I think in most of my classes, I always start with this so that beginners will understand more about how each component fits in the big picture. So here is the big picture overview of machine learning or deep learning. So this explanation would take a lot of time, but it helps you to understand more about the in-depth flow of these things. So let's say you have some data sets. So the dataset has two parts. One is just a input features, label, and output. So we call output as label dependent features. We call input data as some x, data input features, independent variable, we call all these names. So for simplicity, I'm going to call this X and Y. And then we can have any number of model architectures. So let's say you have some model, let's say linear regression for simplicity. So this is your model. This linear regression model has lots of parameters. They are called weights and biases. So initially those weights and biases are very random numbers. And during training, we will learn these weights and bias that reduce the loss function. So that's the goal. So initially this is very random. By using this, by feeding your input data to the model, you get some output features, output values, labels. We call this as y cap, y hat. So this is our predictions. So now you know what is y and what is predictions. You can compare and calculate the loss. For example, let's say for a label 2, your model predicts 2, then there is no loss. It's a perfect model. But for label 2, for data 2, your model predicts 4. Here the loss is 2. The difference is 2. We can have different loss functions like mean square error, mean absolute error, root mean square error. So after calculating the loss, we can find the derivatives of these weights with respect to the loss. What does it mean? So it means, let's say I have assigned a weight equal to 0.1. What if I change the weight to 0.2? If will my loss increase or decrease? So that's a derivative. You calculate the derivative. If the problem is simple, you can calculate by yourself. Otherwise, you can use some libraries like PyTorch or TensorFlow. So after calculating those derivatives, you can update these weights and biases. So this is gradient descent update. I think this is a very good flow. So in today's class, we will understand cross entropy. So where does this cross entropy fits here? So as I said before, if it's a linear regression, you can use mean square error, mean absolute error, and root mean square error. And then you can find the derivative of, let's say for regression, what is your loss function? Loss function is, let's say, root mean square error. So which is just a difference of your input and, sorry, your original label and the prediction. Then you take the square and you sum everything and then take average, then take a square root. So that's loss function. So your goal is to reduce this loss function. So you change your weights and biases. So I'm going to call this as parameter. So change parameter with respect to this loss. But for classification, so classification means, let's say you have some image, you can predict what's in this image. Let's say this is dog or cat. In this case, this is classification. So while solving classification, we use a different kind of loss function called cross entropy. So there are a few more, but this is the most widely used, cross entropy. And we change our parameters to reduce this cross entropy loss. Change parameters with respect to this cross entropy loss. So now you understand where this cross entropy fits in the big picture. Then we are going to see regression and classifications. What does it mean? So it's a different data sets. Like for regression, we will use our output is continuous. But for classification, it's called discrete, whether that's output is like cat, dog, sheep, or anything else. And what's this PyCaret means? So it's a AutoML library. So you just put your input data and output data and assign some task, and it will build lots of models for you and find the best models. So where does this Pandas profiling comes? So this helps you to understand more about your data. This is a EDA library, which is exploratory data analysis library. So we do lots of exploratory data analysis to understand more about our data. Uh, so it's a very creative process. It takes a lot of time, but if you are using this Pandas profiling library, it's automated process. It has so many tools and techniques automatically inbuilt on this library. So you just run 1 or 2 lines of code and you can get some report. So this is way if you use these tools at work, like or any other problem solving, you can save a lot of time. So we will learn all these things today. So now I'm going to start with Colab, Google Colab, and then explain cross entropy so that we can code along. Okay. So this is Google Collaboratory. So you can just type Google Colab on google.com and you'll be redirecting to some website like this. Maybe your layout or theme may be different. Maybe it's a white color. So I am using a different theme. That's why it's a different color. Here you can type anything. Before that, you have to connect. So there is a button called connect here. It should be somewhere here. I already connected. Otherwise, you will see something like connect. Click connect. Then after connecting, you can type anything like 1+1 and you can get the output. You can print something, Python function, like any Python stuff. It prints, so you can type all your Python code. It's a Jupyter notebook on Google Colab. So for most of our task, we will be using NumPy, Pandas, PyTorch, Matplotlib as a backbone libraries. We'll see one by one. So now let's talk about cross entropy. So what is entropy? Before talking about cross entropy, let's talk about entropy. So this entropy tells you uh, if there is any information gain in the system. For example, if there is everything runs smooth, the entropy is less. So it looks like this curve. So let's say here the probability is 0.1. Let's assume this is 0.1. And here the probability is 0.9. In this case, there is no uncertain because 0.9 is high probability and 0.1 is low probability. There is no uncertainty. But in this range, like 0.4 to 0.6, there are so many uncertainties going on there. So our entropy should return a high number for this range 0.4 to 0.6 and low numbers to 0.9 or 0.1. So the equation is like pfx log pfx. If you multiply these things, you will get a negative number. So you use one more negative. So you'll get a positive number. So if there is a lot of uh, uncertainties in the system, you will get some high entropy value. So the entropy will be higher if there is any lot of uncertainties. Let's check this with two numbers. Let's say the probability of an event is 0.5. You may expectations is high entropy value. And let's say another example 0.9. Here the probability is very certain, so that you will expect low entropy value. So let's calculate this first and then we'll come back and understand more about entropy and cross entropy. So I'm going to use a library import numpy as np. So case one is 0.5. For 0.5, our expectation is getting high entropy value. So let's find this 0.5 multiplied by np.log of 0.5. So this is one event, and also there is another event of not happening is again 0.5 multiplied by np.log of 0.5. You will get a negative number. To make it positive, you use a minus. We are getting 0.693. So this number, let's say this number is higher. So now let's do the same thing for 0.9, case 2, 0.9. So 0.9 means there is no uncertainty. We are very sure that 0.9 going to happen. 90% of the chance, 90% of the chance this is going to happen. So there is no uncertainty. So in this case, we expect a low number. So let's do that. 0.9 multiplied by log of 0.9. What is this? So this, if this happens means what is not happening? It's 1 minus 0.9. So that we are doing it for a complete system. So this number is lower, 0.32. Here the number is higher. So this tells about the entropy. So now let's try to come up with some loss function. So now I hope you understand about entropy or what's the logic behind this value. So this is very important. So this equation tells what's the entropy of a system. If it's like 0.5, you will get some high number. If it's 0.9, you expect low. And also for another case like 0.1, you expect low, because we are very sure that it's going to happen only 0.1% of the chance. Expect low. Okay. So let's keep this in background, and then we will talk about some more functions, and then we will connect all these things. Okay. Let's say you have some input data. Let's assume this input data can be a picture of cat, dog, and elephant. So there are three classes. So this is your input. I'm going to call this as X. And what you have lots of different layers. So let's say here there are many layers. So in those layers you do lots of multiplications, and at the end you will get three numbers, right? One for cat, one for dog, and one for elephant. So let's say this image is dog. Let's assume this is dog. Here you will get numbers like this: minus 2.3, 5.2, 3.1. So we call these as logits. So this doesn't tell anything about the probability. So these are some, after doing lots of multiplications, you will end up getting some numbers like this. So now our goal is to convert this number to a probability value. Some probability like 0.8, 0.1, maybe this is, let's say this is also 0.1. So if you do, we'll get some different numbers, but let's assume you're getting some probability value. So this is, you're getting something like probability value. because if you sum everything, you will get 1. And by seeing this number, you can say 80% of the chance this image is dog. So how to convert these logits to probability? There is a function called Softmax. So I'll explain what Softmax mean now. But before that, I'll try to uh, make it complete. So let's assume somehow you calculate this probability. After this calculating this probability, you compare this with our true value. Our true value is 0, 1, 0. If you compare these two things, we can come up with some loss function. That loss function is cross entropy. So before talking about this cross entropy and this loss function, I'll explain how to convert. Let's focus on this part. How to convert logits to probability using a softmax function. So softmax is nothing but take exponential of all the values like minus 2.3, 5.2, 3.1, take exponential and then divided by sum of those exponential values I equal to 1 to n. So this is softmax function. So now let's use numpy to calculate these value minus 2.3, 5.2 and 3.1. Let's try to calculate the softmax. So I'm going to call this as logits. Minus 2.3, 5.2, 3.1. So these are our logits. You can see it here. These are logits. We are going to somehow convert these logits to some probability value so that we can compare with the truth and calculate some loss function. Okay, logits ready. So now I'm going to do softmax functions. So np.exponential of logits, you will get some number, right? 3 numbers. So this logits convert everything to positive range. So minus 2.3 converted to 0.01 something. So this is in scientific notations. So it converts everything to a positive number. Now divided by sum of everything. Here you can see a probability value. This is 0.0004. This is 0.89. This is 0.01. Sorry, 0.10. So here you can see how we converted this to a probability value. So if I sum everything, the rule for probability is if you sum everything, you should get 1. np.sum. So you are getting 1. So this is 1. So there is some floating point going on here. So this is 1. So we converted everything to probability. So this is our logits. We converted to probability now. Now let's compare this with truth and come up with some loss function like cross entropy. Okay, so now our goal is to compare these two. Softmax, we are going to compare this with this and then come up with some loss function. So our loss function is nothing but minus sum of, this is, let's assume this is predictions. P of x and q of x, log of q of x. So let's say this is predictions and this is truth. We are going to use this as our loss function. So if you see the above this system, which is the same, right? Here we are using p of x and log of p of x. But here if you see, this is p of x multiplied by log of q of x. So why it's q of x? Because p of x is our prediction that has a some distribution, and q of x your truth. So that's a different distribution. So we are using two different things. That's why the name cross comes from. Cross entropy, we are finding entropy between two things. One is p of x and another is q of x. But in the entropy, there is no q of x. We are just finding the entropy of the system using only the p of x. So this is just entropy, and the name cross comes from using different distributions. So this is p of x multiplied by log of q of x. So this is cross entropy loss function. So we will try to calculate cross entropy loss function by ourselves, and also we will use PyTorch library to calculate loss functions. So let's take this problem, logits. We found softmax, so I'm going to call this as softmax value. And I am printing the softmax value. Okay, so what is the truth here? The truth is this one, 5.2. So this is our truth, because this, let's assume this is dog, cat, dog, and elephant. So we are getting high value for 5.2, and our true value is, I'm going to call truth as like this so that you will understand better. 0, 1, 0. This is our truth. So now we are going to find cross entropy. So let's try to find the cross entropy, which is nothing but this original multiplied by 5.2 log of minus 1 multiplied by np dot log of another distribution, which is 5.2. So now we'll use a PyTorch library to find the same. Import torch, import torch.nn. nn dot cross entropy C plus. I'm going to assign this as this one. So now the goal is to convert everything to PyTorch tensors so that we can find those entropies. Otherwise, it may throw some error. Let's try to calculate this without converting to torch. So you can see the error message. C loss of what is the prediction? The prediction is logits. So this just takes the logits. And what is the truth? The truth is 1. So you will see some error message, and then we'll correct the error message. Okay, you can see the cross entropy loss argument input position 1 must be tensor. So we passed array, it should be tensor. So now let's convert this to a tensor. I'm going to create few more cells, convert everything to tensors so that we can use those libraries. Torch.tensor and specify the d type equal to torch dot float. Okay, here we converted to tensor. Likewise, do the same thing for prediction. Our prediction is just 1. So here you can do it directly. Torch dot tensor 1. Okay. Okay, so it takes one more dimension because this belongs to the same input. So we are just using one data. If you are using one more data, you add few more numbers like this. Okay. So this tells we are getting 0.1160, and what is log 5.2? Okay, so we need to take this one, softmax 0.89 log of you will get a negative number and multiply by 1 minus 1. So both are same, almost same. Here the numbers are a little bit longer, but it's almost same. So now we calculated cross entropy by ourselves, and also we used a function called cross entropy loss. So in cross entropy loss, there are two things. We need to understand two things. One is, so let's talk about this function cross entropy loss in PyTorch. In PyTorch, there are two important things to know. One is it takes logits. So it takes this spot. It just takes this spot and calculate the loss. But for if you see the equations, you are using softmax. So if you see the internals, cross entropy function is implemented using two things. One is log softmax and then negative log likelihood loss. So there are two different functions that's combined using a single function called cross entropy. And another important thing is, if you see the labels, it's not taking the labels as 0, 1, 0. We just need to tell them the label is 1. For let's say the label if 2 means just enter 2. In our case, this is 1 because 0, 1, and 2. If the label is 2 means you just enter 2. So you no need to enter, if this is one hot encoding, just enter the label as it is. So these two are some of the design choices from cross entropy loss function. So enter labels as it is, not as one hot encoding. Okay. So now we got some number. Our goal is to reduce this loss. We do some trainings to reduce this loss. So I hope you understand this cross entropy loss. So now coming to one of the previous questions. Okay. Howard asked, but this XML has 3 classes, not 2 are binary. So the cross entropy computation would be a bit more complex. The answer is no, it's not a complex. The reason is we are just taking this one. So this is the output. So we are just taking this one and finding the log. We ignore minus 2.3 and 3.1. We don't care about those things. We just care about our real truth value, which is 5.2, which is 1. So if you see the loss softmax functions, so loss of the softmax function, it uses all those numbers, right? You're summing everything and calculating one by one. So this includes everything. But if you optimize only this one, the others will be automatically optimized because we are including everything here. So our goal is to just focus on the truth. Others will be automatically optimized. So you don't need to worry about getting this low or getting this low. Just focus on getting our truth low. So even if it's like 100,000 classes, we just focus on our loss function is very simple. Just take the truth index and then find the log. That's it. That's all. I think if you read this one more time, you will understand. It's still the same. We just take the logic value belong to the correct class, because in softmax, if we optimize one value belong to the correct class, the other two classes or values will be automatically reduced to low numbers because of the exponential. If you optimize one exponential value, the others will be automatically optimized. I hope this makes more sense now. So I'm going to share this with you, and let's take 1 minute, 2 minutes break. Please download this data. So you can just click download. Maybe it may ask you to log in. You can spend some time downloading this data, and we will use this data to build some models. I'll see you shortly. I hope you have downloaded this data. So we'll import this data to Google Colab. So if you click this folder icon, you can right click and choose upload. Then you can upload your file. So it's uploaded here. You can see it here. Import os.list directory. You can see the file name appears there. List typo. Okay. Our data lies here. So we are going to use Pandas library to import this data and see some of the, we will see start exploring some of the binary classification functions. Import pandas as pd. So df equal to pd dot read csv hot dot csv. Df dot head. So this has lots of features: age, sex, CP, cholesterol. You can see heart disease dataset and try to understand more about what each field means. So chest pain, resting blood pressure, you can go through it. And the one we care more about is the target, this one, whether someone with age 63 with these conditions, whether someone has, whether this person has a heart disease or not. One means there is a heart disease, and 0 means there is no heart disease. So the one we care more about is the target. Let's see the distribution first. So this dataset has 165 heart patients and 138 are normal people. So it looks good. So initially you can do lots of exploratory data analysis to understand more about each feature and some of the correlations between each features and try to come up with new feature ideas. But for simplicity, I'm going to directly use Pandas profiling library. So this Pandas profiling library, I need to import first. So before importing, let me check if this is available on Google Colab. If it's not available on Google Colab, we will install that first. Otherwise, we can directly use that. Let's check. I think in Google Colab, it's already pre-installed. No need to install it again. So now let's go here and find the syntax. So just a simple function, profile report. So heart disease report. Okay, I think I need to install recent versions. Let me check this one. Okay, so I need to install recent versions. There is a clash between Pandas and Pandas profiling. So that's why you're getting some error messages. Let's try to install another version, or let me install directly from GitHub. Also let me check Pandas versions. So we are using 1.1.5. Let me first update Pandas and see how it goes. Pip installed Pandas update. So it's going to update the Pandas library. So it found 1.1.5. Okay, and it successfully uninstalled that one and installed the recent version. It asks me to restart my runtime. Click restart runtime. Yes. So you can see it's creating a new virtual machine for me. Okay, it's done. Now let's import Pandas. Okay, now let's check the version. It should be the latest version 1.3.4. I'm going to uncomment this one. So now let's run this and see if we are still getting the error message. Okay, we are still getting the error message. Now let's try to update Pandas profiling. Okay, it installed Pandas profiling. It asked me to restart the runtime. Let's do that. Okay, I have restarted my runtime. Let's comment and let's rerun everything from scratch. Okay, now everything works. Okay, so it's good that you have seen some of the debugging steps. Okay, so now we installed this library from GitHub, and now I'm going to run the profile. That is profiling and explorer. Okay, let's copy this, replace. So we are going to see that inside the notebook. In most cases, sometimes I export this as a HTML file and I open it on my browser. But for simplicity, this is a very small data set. We are going to see everything in the same notebook. So now let's run this one and see what are we getting. So it's creating a profile for you, generating report structure. Or let me, okay, it's almost done. So I can't see anything because it says there is an IPy widget is not yet fully supported on Google Colab. So now let's use one more function. Maybe let's try this one. If everything fails, this should work for sure. Okay, it's good. So here you can see the report of this data. This has 14 variables, 303 data points, and there is no missing cells. And you can see the distributions of each features. So it saves a lot of time when you are doing some real work. So just it helps a lot. You can directly share these results with your team. You can find the distribution, common values. I think 19 people with the age 58 in this data. Extreme, only one guy with 29. Likewise, you can see the distribution. So we care about this one. So this is the one we are going to predict. And you can see some of the interactions. So I'm going to minimize my screen a little bit so that you can see it fully. So now let's find the interaction between cholesterol and the sun. So let's try to find cholesterol and age. Okay. Or maybe age in the X, cholesterol in the Y. I couldn't find any increasing pattern, but there is some pattern here. and you can see the correlations. Age is highly correlated with this one, CA. What is CA? CA, one second. CA is the last two. I think this is the slope of the exercise. Okay, cool. And you can see the first few rows and last few rows, and there is only one duplicate rows. This is good. So now let's quickly build a model using this data. So I'm going to quickly build some models now. So the first step, so this is our data, df.head. So I'm going to zoom. Okay, so this is our data set. We are going to build some models. The first step in model building is try to split the data into training and validation data sets. So ideally, you split your data into three parts: training, validation, and test. But for simplicity, I'm going to divide it into two parts: training and validation, because we are not going to iterate different model techniques. So we'll be doing just a few. So it's okay to have just training and validations, not test. So how to divide this data into two parts? You can do it manually, or you can use some library like sklearn, scikit-learn. From sklearn.model selection, you import a function called train test split. So you can use this function train test split, and you pass your data frame with x details, drop target, axis equal to 1. So we just dropped target, that is your x, and your y is target, df dot target. Test size, maybe 0.15% or 15%. So it's going to return 4 data frames. So I'm going to capture those 4 data frames: x train, comma, x validation, comma, y train, comma, y validations. Okay. So now we split our data into two parts randomly. So now let's check the shape of train and test split. Okay, our training data has 257 data points and our test has 46 data points, which is validation. Okay, so if you see the data, one is different range and another is different range. Here the range is high. So everything is in different ranges, right? We need to convert everything to the same range with mean 0 and standard deviation 1. So if you use standard scaler, you can convert everything to mean 0 and standard deviation 1. So from scalar, so that maybe in the next class I will talk more about why should we do these things. The short answer is it helps the training faster, because if everything is in the same range, you can do gradient descent update in the same way for each features. Otherwise, if one feature is in different scale, the derivative are in different range, so it affects the training. So if you convert everything to the same range, it fastens the training. And in the next classes, we'll learn more about some in-depth understanding about what's going on there. Import standard scaler. So I'm going to fit and transform using my training data. Fit transform x train and x val sc equal to sc dot transform, not fit transform, just transform, because we are going to learn mean and standard deviations from your training data, and we apply the same thing to validation data sets as well. So now everything looks good. We are going to use a PyTorch model. Before that, PyTorch accepts only the tensors, not NumPy or Pandas. We need to convert everything to tensors. Let's do that. Train sc equal to torch dot tensor xtrain dot underscore sc comma d type equal to torch dot float x val sc equal to torch dot tensor x val sc comma d type equal to torch dot float. Then let's do the same thing for our labels. Our label is ytrain torch dot tensor ytrain dot values. This is a series, and d type equal to torch dot long. Then y val equal to torch dot tensor y val dot values d type equal to torch dot long. Okay, input. Okay, I need to import torch and import torch.nn as nn, then import torch.nn.functional as f. Okay, these are standard imports. Okay, now let's quickly create a model. So our model going to inherit everything from nn.module class. So use super init. Then let's create some layers. I'm going to create the first layer, nn.linear of what is the input size. The input size is 13. So my model is going to accept 13, and maybe I can output different numbers like 32. Okay. Now let's add one more layer to nn.linear. This second layer takes 32 from the previous layer and it outputs 16. And let's add one more layer, L3 equal to nn.linear. This takes 16 as an input and output two numbers, one for probability for the heart patient and another is normal. Def forward self x. Okay, here your x is the input data, which is a PyTorch tensor. We are passing this input data to L1 and you're getting some output. Let's put that to nonlinear layer, relu function. So relu just change anything less than 0 to 0. Just ignores the negative side and it keeps the positive side. And let's do the same thing for other layers. f.relu of self.l2 of x. Okay. Now return self.l3 of x. Okay. Here is the quick question to Pointer. Why I'm not doing any relu in the last layer? The answer is we need to return logits. If you are using cross entropy function, we should return the logits. So you can see it here. We are just returning the logits. Cross entropy function handles this. It knows how to convert logits to probability, and from the probability, it knows how to calculate the loss. Okay. So that's our model. Model equal to model Let's see the model. So this is your PyTorch model. So now let's create loss function, which is cross entropy loss, and gradient descent optimization. Torch.optim. You can use stochastic gradient descent or anything else. Let's use Adam. And you need to pass the model.parameters and some learning rate. Okay, looks good. Now let's do the training loop. So we are going to calculate the training loss, and we are going to calculate the validation loss. Then we are going to calculate the training accuracy. Oh. Also, we are going to calculate validation accuracies. Okay, let's do for epoch in range. Let's do maybe 150 epoch. The first step is make the prediction ypred equal to model of x train sc. If you put this, you will get some predictions. That's a logic values. Maybe you can see it here. You are getting some logics. So initially, without any training, these are very random numbers. These are logics, they are very random. Now we are going to do some training. What is the loss? If you pass these logics, you can calculate the loss. Criterion, ypred, ytrain. So we can calculate the loss, cross entropy loss. And then after calculating the loss, you can do gradient descent update. So optimizer dot zero grad, then loss dot backward. It's going to do backward propagation to find the derivatives. After finding the derivatives, let's do gradient descent update, optimizer dot step. Okay, if I run this, it's going to train. That's all, but we are going to calculate these things so that we can understand how well our model trains. Train loss dot append loss dot item. Okay. Then train accuracy dot append. Let's try to find the accuracy. To find the accuracy, we need to find the maximum of these two numbers. How to do that? I can use argmax. If I use the argmax function, it tells me what is the maximum value, if it's index 0 or index 1. So let's do that, ypred dot argmax. So there are two ways of argmax, finding this index or this index, this way. So we need to tell x is equal to 1, which means find between these two. Okay. So this going to create 0 or 1 based on the position. Now compare that with truth. Ytrain. Okay. ypred.argmax equal to ytrain, which is good. Now let's convert this to float. So it should be 1 or 0. So we are converting this to float, and then take average. So that's training accuracy. Okay. Now let's do the same thing for validation datasets. To do validations, we use torch.noGrad because we are telling the torch not to find any gradient, because whenever you are doing some calculations, it's going to find some gradients. We don't need to find gradients for validations because we are not going to use validation dataset in our training. So validation is purely for how well the model performed. We no need to calculate the gradients. We no need to track gradients, so we can use with torch.nograd. So ypred val equal to model of xval xc. Okay, it's going to give me y predictions for validations, and then I can calculate the loss equal to criterion y pred val comma y val, then validation loss dot append loss dot item, then validation accuracy dot append. Let's copy paste the same thing. So this is y pred val. Compare this with y val. Okay, I think we are good to go. Let's run this and see if we are getting any error. No error. That's good. So now let's plot the training loss and validation loss. Training loss, plt.plot val loss. Okay, I need to import matplotlib library. Import matplotlib.pyplot as plt. Okay. I think I need to do percentage matplotlib incline. Okay, yeah, it trains really well. Initially the loss is high. After some training, your training loss getting low, and your validation loss, there is no improvement after epoch 100. Okay, let's try to find the accuracies. plt.plot train accuracies and plt.plot validation accuracies. It's good. We are getting close to 90% accurate. So this looks good to me. I think with few lines of code, we have trained a neural network, a PyTorch based model on this heart disease dataset. So if you collect this information for a new data points, you can accurately, like 90% accurate, you can predict someone has a heart disease or not, which is a good model with a small data set. So this is one way of tackling this using PyTorch based. Now let's assume you want to try few more models. Instead of writing a long way of trying lots of iterations and hyperparameter tuning, you can use PyCaret library. I'm going to use this PyCaret library after a long time with you now. Maybe I'll be making a few mistakes, we'll see. So now I'm going to install PyCaret library. I think the best way to find tutorials on example notebooks. Before that, let's import PyCaret and see whether this is available here. Okay, it's not available here. We need to install by ourselves. It won't take a lot of time. Maybe I can finish the session in 5 to 10 minutes after completing this one. So let's install PyCaret. It may ask me to restart because it's going to install lots and lots of libraries, because this is AutoML and it has lots of functionalities. It's downloading huge files. Okay, while it's running, let's go to the tutorials, regression tutorial. Let's use this. And I think ours is classification, so let's use this one. Okay, so we are going to use this one and try to replicate. Okay, we installed PyCaret. From PyCaret for Colab users, it says I need to run this. Let's run this. Still running. Okay. We already have a dataset. Okay, we can start with this one. Then let's run this one. And let's run this one. I think, okay, cool. I think we have installed all the libraries. So it asks our to restart the runtime. I'm going to restart the runtime. It's restarting, and we can comment these things because it takes a lot of screen scrolls. Okay, let's comment this, and I'm going to rerun my data import. Okay, it's here. Okay, so we have our data df, and we are going to use an AutoML library on this data. Okay, so I have installed the PyCaret. So okay, it says collab mode enabled. So ours is a classification problem. So we are going to use PyCaret classification, import everything. Then we are doing some experiments. Okay. Maybe let me create a, no, because we installed a different Pandas library. That may be a reason. Pip installed Pandas equal to 1.1.5. Let's see if that solves. Restart runtime. Yes. Now the load function gets loader to loader if a YAML file contains symbol. Okay. Let me try this one. Sometimes this may work. Let's see. Cool. Okay, I think it worked. So now we are going to reload the data one more time because we restarted the runtimes. So now I'm going to run the dataset loaders. Okay, all good. Okay, let's comment import, and our data is df. And what is our target? I think the target is target. Okay, you can use any session IDs. Okay, so with this data set, it found these are the features: age, numeric, sex, category, and target label. So I'm fine with this. So I'm going to click enter here. Okay, so let's say if you want to include some new features like PCA component features, you can add it here. So it has so many. Maybe I can show this one. Setup. Okay, it has so many uh, parameters to use. Let's say if you want log experiment, just set log experiment equal to true. So it's going to log all the experiments. Similarly, if there is a imbalance, you can use fixed imbalance equal to true, so that you can use different technique to evaluate your models. Okay, so everything looks good to me. I'm not going to create any additional features. If you want to create some additional features, you just set equal to true. That's all, it's simple. Now I'm going to compare the models. Best model equal to compare models. Let's try to find that. Okay, cool. Thanks, Tim. It's very helpful. So it already built a lot of models. So far, the best model is rich classifier, which is 0.83, sorry, 87% accurate. But our neural network model also performed similar. It's close to 87%. It's very similar. So in this way, you can quickly check what kind of model work well for your datasets. You no need to write lots and lots of code to do that. With a few lines of code, you can accomplish those things. Here, let's say if you found something like XGBoost or like GBM performs well, in that case, you focus more on tree-based algorithms than the neural network. Here, we are getting a good performance for rich classifier. So I will go with neural network approach. So it's still running. I think it handles around 10 to 15 different model types. That includes everything from linear regression to light GBM cat boost models. And in the upcoming lessons, we will try to explore more about these practical aspects of things that may directly impact your work. So I think I'm going to end today's session here. If you have any questions, please ask on our Slack group. If you don't have any invitation to this Slack channel, please message us from meetup.com. We will add you here. And I'm going to share this notebook with you all in this Slack channel. See you all next week. Thank you.